All right, AB Calc. Here we go. So on our worksheet, I think this is worksheet 18. I think it's 18. And there's a couple of them that kind of threw some little mess ups at you guys. So these are special cases. So this is the example they give in the book. And the special case is when you can use logarithm rules or natural log rules to simplify the problem. So, and it's usually when, if you notice, it's like a variable to another variable as a power. If you notice, it's a variable to another variable. So we're going to use our logarithm rules to kind of tackle this. So the first thing I want to do is I want to change this whole thing into like natural logarithm world. So I'm going to grab this and I'm going to take the natural log of both sides. So we end up with something that looks like this. Okay? So once we get this piece here, I can maneuver this around and I'm still going to get the natural log of y, and I'm going to get this drops down and becomes the natural log of x times the natural log of x. So now we've got two of them, which makes it squared. So let's rewrite it one more time. Natural log of y equals the natural log of x squared. Okay, I haven't taken the derivative yet. I haven't done anything. Okay, now I can take the derivative of both sides. So I just did some algebra work. So this is all algebra. Now I can take the derivative. So what's the derivative using the natural log? Well, this ends up becoming 1 over y. Okay? Natural log of the whole thing, it's a chain rule problem. Natural log of the whole thing gives me 2 natural log of x. Oops. Natural log of x times the natural log of the inside, which is, or the derivative of the natural log of the inside, which is 1 over x. So that's how they tackle that problem. I'm going to let you guys kind of finish up the algebra here, because this y makes it in a little funky spot, so don't forget, we pretty much got to flip this thing over when we finish it, but that's kind of how they tackle that one. It's the same thing here. What would I do to both sides? I would take the natural log of y, and I would get the natural log of x to the x power. This can move down, and so I will get the natural log of y equals x times the natural log of x. Now this becomes a product rule, which is a lot easier to work with than this. See, this isn't easy to work with. This is. And then we would take the natural log and we'd get 1 over y with the product rule. So that's the special case scenario. So just know that you have to take the natural log of both sides when you're posed with something, usually a power, like an exponent, not an exponent, a variable to a variable when it comes to dealing with exponents. So then, now we've got this piece over here. This is a different one. It's number, you may not be able to see the glare very well. It's number 7, and it says, you got this piece and they want you to take the derivative. So I'm going to write this in a different little color here. So we want the derivative of y with respect to the derivative of x. Color-coded it here. Derivative of y over the derivative of x. So now, I dropped that stuff here. So now let's rewrite this. So really we're saying what's the derivative of y, which is going to be 1 minus cosine of t. And that is all going to be over the derivative of what sine is, which is t minus sine of t. So now what you do is we're going to end up with we're going to get the derivative of these pieces for y prime. So I take the derivative of this by itself, and I take the derivative of this by itself, and then I can finish the job. So on all the other ones, like 13, 14, 15, so 13 through 16, you're going to set up just like this. They're asking you to take the derivative of what y equals, and then you take the derivative of it, and that'll be your answer. This should be a prime. Okay? So hopefully that gets you started on some of those. And that is for worksheet 18.